Thanks very much, Chris, and thank you everyone for having me here again today. I'm going to go ahead, share out my screen, and we'll go ahead and get started. The one thing I just wanted to comment on real fast is from a couple of those speakers and a couple of those upcoming presentations, for any of our customers that are on the line that are both WAF and DAM customers, definitely join the session with Craig Burlingame. That man knows database security inside and out more than anyone else in the company that I know, except for the person that's going maybe 2 weeks before him, which is Richard St. John, who is also one of our biggest database security subject matter experts, has been doing it for years in some of the biggest companies around the globe. Richard can't be missed. So I just want to give those guys a quick shout out and plug, because I think you will learn a ton about data security in that. But switching gears, we're going to go back over to application security, and specifically we're going to be focusing on API security, and this is the part 2 of our session. So for those of you that missed the last session, we'll do a quick recap of just some of the core points, and then we'll dig really deep into a couple of topics in particular. So I always like to start out these sessions with just kind of some expectations, and these are really just kind of the way that I look at things, that this will be a good session if ultimately you learn what mass assignment is and how to protect against it. So when we started really digging into API security and we started digging into API security vulnerabilities, mass assignment was new to a lot of people. It's not a new vulnerability, but it was something that didn't really get impacted, or a lot of web applications aren't impacted by it. So a lot of people don't really know about it. So this is a really, really fun one to dig into. We're going to spend a lot of time today kind of talking through how it works, and we're going to go into some, I'm actually going to share a lot of code samples. So you guys are going to really get a full, deep understanding of what this is. On the injection side, this is probably the most well understood of the different application security vulnerabilities. But ultimately, what I'm going to try to do is introduce a couple new interesting dynamics to it, and try to show you how mass assignment and injection can actually be used to work together to, of course, wreak massive amounts of havoc on all of your architectures and application stacks, which is never a good thing. As always, we're in COVID. If my internet dies, that's going to be a bad thing. So hopefully it doesn't. Also, the demo gods, they are vengeful gods. And so hopefully they are nice to me and my demos actually work. I'm going to just do a quick toast to them. My dog, she's a sweetheart, but she likes to bark at other dogs all the time. She's actually laying here on the floor right behind me right now. If she starts barking, that will be also annoying. And last but not least, ultimately what we want is we're trying to make this a regular series. We're going through all the different API security vulnerabilities in the API top 10. In part 3, we have tentatively scheduled in Q4. And so ultimately what we want is people to sign up for that. All right. So let's do a quick review of last session and some of the key concepts, and then we'll go ahead and we'll just dive right in. So first and foremost, the reason why we're talking about API security today is because ultimately APIs are the modern day interface to access data. They are the most commonly developed applications in the marketplace today. Every single organization that I interact with and work with is developing APIs, and there's lots of reasons for it. A lot of times you're exposing data specifically to B2B partners and customers, so in more B2B use cases. The biggest reason probably is actually the second one, where APIs power mobile and single page applications. It's pretty common that a lot of organizations are moving to frameworks like AngularJS, or well, Angular, just as the newer versions are called, React, and even different technology like Vue, which provides a single page application. So seamless transitions and everything's really interacting through an API. But ultimately, anything that's developed on native applications that connects out to the internet, it's interacting with an API. Same thing for IoT devices. APIs, most people's interactions with them originally are oftentimes integrating with other products, and specifically in the technology space. And part of that is often around DevOps, CI/CD, infrastructure as code, you know, all of those big things that everyone talks about all the time around automation. To automate things, you need an API. And so a lot of organizations, Imperva included, we expose APIs to you so that way you can interact with us. And of course, last but not least, and when we get starting to get some of the really technical stuff, is when APIs are really the core of service-oriented and microservices architectures. We'll probably make this an entire subsection to talk about because it's a really, really big topic. It's rapidly evolving. A lot of organizations have no idea what's actually happening here. Everyone's kind of figuring out their own things for themselves, so it's an exciting space. Now, as ultimately some of the challenges that we find with this are, first and foremost, when we talk to customers, security organizations find it difficult to control data access because you're effectively opening these up across the board. It's very much like trying to protect web applications only on steroids. Developer errors. They make them in web applications. They certainly make them in APIs, but the problem is they unknowingly lead to sensitive data exposure. We'll talk through that a little bit today. Compromised API keys ultimately lead to breaches. So we'll actually also talk about this one a little bit more in some detail, but probably save this one for the vast majority of the authentication authorization topics. And ultimately, we see APIs really as being a target source for a lot of large data breaches these days. There were obviously some very, very big name ones that happened last year, things like Facebook, where effectively their APIs were abused to be able to steal large volumes of, hundreds of millions of records. This is not abnormal, unfortunately. And so we view this as a primary abuse target and something that we as Imperva are currently focused on quite a bit. So we'll talk through a lot of those details in future webinars, but for today, what we're going to do is we're going to be looking at specific subsets of the OWASP API Top 10. Now, as I talked through in the last webinar, when you look at the Web Application Top 10, which everyone's very, very familiar with, and then the API Top 10, which is pretty much brand new, it just came out at the end of last year, it looks like they're totally different, but then when you actually do the mapping, you find that there's about 70% overlap. There's a handful that don't exist, and we covered why they don't exist in the API Top 10 in the last webinar, so you can go watch the recording. But there's also new ones. And so today what we wanted to do is spend some time specifically on two different classes of vulnerabilities. One of them is new, one of them is familiar. The one that's new here is mass assignment, and the one that's familiar is going to be injection. So as we go through and we kind of look at what the schedule looks like and how we've been breaking this up. So we had configuration management, vulnerabilities, A7, 9, and 10. We're all in the last one. Input validation, so focusing on mass assignment and injection. That's currently today. We'll look at data harvesting and exposure in the next one. And then we'll get to the authentication authorization issues in part 4, part 5. Those are massive topics in their own right. We'll probably be bringing in some partners to talk about those in more detail because with Imperva specifically, we don't do a whole lot around authentication and authorization. So it's a good one for us to talk to some of our partners that we work with to help solve these problems for customers. All right, so let's just dig right into mass assignment. We're going to go pretty fast into some of these things. And what I want you guys to do is if you have any questions, please just stop me. We're a small enough group here today, and I think the content itself, we can skip around on things if we need to. So please just, don't be shy and just reach out if you have any questions. But I'm going to start things out giving you a scenario. Everyone's going to go and put their developer hat on today, and you're going to live what it's like to be a developer, basically. And part of being a developer is basically you are given an assignment or a project or something of that sort. And basically, as a developer, you're responsible for developing a new users and accounts microservice. One of the user stories, everyone in development basically gets user stories from their product manager, and it's pretty simple. It states, as a user, I want to be able to update my user profile so I can ensure that my information is up to date. Very basic user story, very boring. Most user stories aren't this pedantic, but at the same time, this is the type of things that product managers get paid to do and developers have to deal with. So as a developer, basically can take this, and the first thing he's going to think is, all right, well, we're going to need to create some REST endpoints here. So as a quick review on the REST endpoints and generally how they work, you have the various HTTP verbs, so the gets, post, put, delete, patch as well. And then you have your resources. And then ultimately, as he's thinking about how do I build this out, how do I structure this API, it's pretty straightforward. He's going to say, well, if I'm creating a generic service, it's going to be used by lots of others in the organization. I might do something like get/user, returns a list of users. This is an API that maybe is used for both internal and external purposes. So they might decide, well, or a microservice for that point. So they might say, let's create a get user API endpoint, but we're only going to expose this internally. We might not expose this externally. That's fine. It's something that will happen. The key things and where they're really going to focus in on, though, is going to be the actual actions that allow you to create or modify objects. We always talk in developers, they always talk about CRUD, create, read, update, delete. And the way that you can always think about this from an API perspective is the create operation generally refers back to the post operation or post method. The read operation is usually associated with either the get/user or get/user some user ID. The update in the CRUD is usually going to be either your put or patch methods, and I'll talk about those in just a second. And then, of course, delete is very obvious. There's a very handy HTTP method called delete that you can use to delete. So this is usually how a developer's probably going to structure this API. And so he's going to go and he's going to start writing some code. So I've got some code here. This is some beautiful code that I wrote for this. It's all written in Node.js and TypeScript. So I'm going to walk you through just exactly what this is doing. And very briefly, we'll kind of talk about just generally how this works and why the developer is structuring the code like this. So the first thing is they basically are going to say, okay, well, let's create a service that is basically able to take the user ID that I want to update and the updates that we want to apply. Now they might say, well, we have to implement this multiple times because we have a put and a patch method as well as a post method to be able to, or the put and the patch method at least to be able to go and say, I need to be able to update this and apply a full update, or I need to be able to patch it and apply a partial update. So effectively what they might say is that, okay, I'm going to create a method that can do both basically. And then ultimately, they're going to go and they're going to create their SQL queries, and they're going to go ahead and use parameterized queries, which is great. We love parameterized queries because they're generally safe from SQL injections. And then each API endpoint that they'll wrap this around is probably going to be something that is going to be have its own validation logic on the front. And so this is really just handling this update process. So in here, and kind of the bulk of the key, what they're doing is because this is applying updates that are not only to the full object, but also to the partial object. What he's saying is for all the keys that exist in the updates user object, basically, so key value pairs, I'm going to iterate through them. And where I see one, I'm going to go ahead and I'm going to create this SQL query that basically starts to create this set values. So key equals parameter index, and then it basically goes and pushes the keys to an array of effectively being able to go and update using parameterized queries. So the params basically get pushed here, the query gets pushed here, everything looks good. The developer goes and he tests it. So basically on the put method, he goes and says, you know, username, email, first name, last name, phone number. And then on the patch method, which is only going to be a partial update, he's just going to say first name, last name. Okay, great. So what this means is that in the put method, what's going to happen is everything that's listed here, username, email, first name, last name, phone number, that completely replaces the object on the back end. On the patch method, only the two parameters that I specify, so full versus partial updates. All right, everyone bear with me for just a minute. So he goes and he tests this. Great, it works awesome. Everything that I just specified in there in both full and partial updates, they come back. We get the full user updated after I went ahead and specified that, updated email, updated name, everything looks good. So what's a developer do? They ship it. PMs are happy, everyone's starting to hit their deadlines, they're living the CI/CD dream and shipping updates on a regular basis, and everything is absolutely gravy. Until you go and someone starts to actually test this a little bit further and they start to throw values at it that weren't necessarily expected by the developer. So if we go back here and we look at one of these variables that came back, well, we see we've got some information like last login, and we had some information like user ID. So basically, we're able to go ahead and start specifying last login, and when we do this, last login gets updated. Okay, well, last login's not a terribly important field, but what about something like user ID? And ultimately, what this is an application that's vulnerable to mass assignment. The problem here basically is that we untrusted some user input. So we basically had everything that came in from the user object. We basically blindly took it. The attacker was able to guess common sensitive fields. The reason why I mentioned before that we didn't usually see this happen that much in web applications, but we see it a lot in APIs is because, well, APIs are returning back the actual full structure of a lot of what the data model looks like on the back end. And so it was very easy for me to go and guess sensitive fields because if I look at this, I'm returning the data model. It's basically coming back and I see last login and user ID are different fields. So I can pretty much intuitively look at this and say, well, these are things that are probably associated in that database table, and I can now go ahead and actually take this and try to update these things. And so this is the reason why we are seeing this so much in APIs, is because the guessability of the APIs, the amount of information that actually gets returned, makes it very easy for an attacker to be able to actually go and start to test these things. And now, most importantly, one of the biggest reasons why this vulnerability exists, there's nothing too inherently wrong with this code. There is stuff that's wrong with this code. We'll get more into this later. But ultimately, the biggest problem with it is that aside from untrusted user input, it's also not explicitly assigning values to sensitive items. So we're not doing a one-to-one mapping where we basically say, if I have basically a username object, I'm going to explicitly apply updates.username to that object. And same thing with any of the other variables that we're updating, like first name or last name. Some developers don't like to do that because if you have 100 things that you have to update, then it's really tedious. It makes your code really messy. But ultimately, the alternative method that you have is basically declaring what are protected or sensitive fields. And so these are some of the options and some of the ways that you're able to basically go and protect against this. And so what's the worst that can happen? Well, these are some examples that I was able to find online. And these aren't, things that are just in open source projects and things that no one's really using. These are massive tech companies that had vulnerabilities around mass assignment. This one was one that I found on HackerOne. This was for New Relic, where users were able to basically do privilege escalation. They were able to enable privileged features using a mass assignment vulnerability, which is kind of cool. They basically were able to go and make their accounts better. This one was GitLab, the second one here, where basically this allowed any user to be actually able to modify and put projects over in other namespaces or other project accounts. So you could basically upload malicious Git repositories to other official accounts, which is potentially really bad. And this one in particular, this is an older one, but this one was one of the earlier, very, very large, impactful breaches that we knew of related to mass assignment, and it was actually around GitHub. You can still go and find this blog. It's posted online, but GitHub had to do an entire breach investigation as a result of this, because basically what ended up happening was you could take a SSH key, your token that you use to be able to go and push projects, and through a mass assignment vulnerability, you're actually able to go and update pretty much any project around. And so they found that you were actually able to go and start creating and giving yourself permissions to be able to go and adding your public key to any project that you wanted. This basically gave massive unauthorized access to pretty much all of the projects that were in GitHub at the time. So this was a huge, huge vulnerability for GitHub that they had to deal with, and it was all based on a mass assignment vulnerability. So there's lots of other examples that are out there. This was only a subset, but you can go online, you can look at not just the public CVEs, but you can also go and look at things like HackerOne, where I also found mass assignment vulnerabilities getting reported in platforms and services like Uber and a bunch of other ones. So this is not just limited to a handful of open source developers. Big, big tech companies have been making these problems and these mistakes in their APIs as well. So why does this happen in the first place? Well, I gave an example before where basically we were going through and we were doing this iterator. Now, ultimately, a lot of developers, they don't use raw SQL queries or a data access object type of methodology. They'll use something that's called object relational mapping. And so with SQL and a SQLized ORM, one of the things that as we're researching this and kind of looking at, well, what do ORMs do and how does this work with them? Ultimately, what we found was that it's actually even easier to implement this type of vulnerability using an ORM. So a good example here is I could do this actually in one line. So just a simple user.update request body where user ID is user ID. Very, very easy for me to basically take this untrusted input and just apply it directly. And the ORM actually did all the damaging work for me. Now, on the other side, you can also do things like object.assign, where you're basically taking the request body, mapping it onto the user so it looks like it's not necessarily fully untrusted, and effectively then doing a save on the user. So this is a point where you're fetching the latest record and then you're updating it that way by saving it. Exact same method applies for non-SQL databases as well. So this is another type of vulnerability where it doesn't actually matter what the data store is on the underlying side. It could be a SQL database. It could be a NoSQL database. In MongoDB, if we're using Mongoose as the ORM, which is probably the most common ORM, ultimately it has the exact same syntax and exact same method as the SQL version of this. And as you can see, the code when I had to write this out manually was fairly long. When I use an ORM, it was super, super easy. Now, some of the biggest examples and challenges with this are, number one, it's really hard to find with static analysis and dynamic analysis tools. What we've generally found in looking at API security as a whole and talking with customers, most of our customers, they have their SaaS tools. These are your Vericodes, your Fortifys, your Web Inspects, things along those lines. They're great tools. They do what they do fairly well for certain types of vulnerabilities, but there's other classes of vulnerabilities that they have a harder time spotting, and in particular ones that are more abusing business logic, like this is. Those tend to be really difficult for the SAST and DAST tools. I was not able to find any sort of confirmation of any SaaS tool is actually able to find any sort of mass assignment vulnerabilities. If anyone has heard of one that does, please let me know. I would love to hear about it and talk to any of the teams that are doing those. And then ultimately on the DAST side, one of the other challenges that we find is that API testing is pretty hard. There's not a lot of really good API testing tools that are out there outside of what developers already use today, but there's none that are really security focused that are really going and testing these types of vulnerabilities. So it's hard to find. Manual pen tests are probably the best way. Manual pen testers are really good at knowing to look for these types of vulnerabilities, or at least quality ones are. And so that's where a lot of times for companies that end up having mass assignment vulnerabilities, they find them from either a manual pen test that they've basically have gone and sanctioned, or they find them through things like bug bounty programs. And that's actually the reason why when I was first looking at this, I was able to find a large number of examples on HackerOne of these types of vulnerabilities where they basically had a bug bounty program. The bug bounty program is where the hackers were able to actually go and find this. So that's the first thing, generally pretty hard to find. The second thing is that active exploit attempts are not easily detected. I'm going to be just very blunt around this right now. It's pretty hard to know when you're actively being exploited because, again, this is something that's targeting more of a business logic vulnerability. What's to say that a user shouldn't have been able to update last login? It's really something that you are thinking about as a developer, whether you want to allow this or not allow this to happen. There were certain fields that were protected. There were certain fields that weren't protected. No automated tools, WAF included, are really going to be able to tell that, understand that difference without being explicitly told what is and is not allowed effectively. And the last but not least here is that ultimately privilege or mass assignment can lead to bigger problems. And as I kind of talked about before with the GitHub vulnerability example, privilege escalation is certainly a good example. I'll show you another one in just a minute here. But ultimately, it's one of those things where there's a terminology that developers like to use, something called a code smell. And it's basically like if the code looks like it stinks, it probably stinks. And this code stinks, and mass assignment's generally a code smell, which often probably explains that there's a bigger issue at foot, which certainly in this case there is. So real fast, what are some of the code level fixes? Well, let's just walk through this really quickly. Again, bear with me here on all the code examples. So if we look at the SQL ORM example, when I fix this, it's pretty straightforward. I can do this object mapping like I was doing before. The SQLize ORM actually has protections built into it that you can use that basically say, these are the fields I want to specify. So this little bit here where it says user.save fields, username, first name, last name. And this specifically says, these are the only ones I want to allow update, ignore all the rest. So here's some, fancy looking code that's overwriting this really quickly. And then here's the specific fields that I want to update. Everything looks good. Another couple examples that you can do are where you're more explicitly defining the parameters. So what I basically had said earlier, where I'm saying if I want to create an update object, I'm going to say username has request.body username, first name, request.body that first name, last name, request.body last name. I'm very much explicitly defining these. You would still want to do some form of input validation to these different fields. You want to make sure that it passes all of your other checks that you need to do. But ultimately, this is how you can prevent against mass assignment. It's a little bit more tedious, so that's why developers hate doing it. But ultimately, it's the safest method. The other method that you can use to basically help to protect against this is you can create a list of protected fields. Or you can annotate protected fields depending on the language that you're using. And so in this case, you can see I'm creating an array that says these are protected fields, user ID, last login, other protected fields, basically whatever I want in here. And we can just go and do a quick map. And if I see the protected field in the list that's applied by the user, I'm just going to delete it because we just want to get that out of there. And then I can basically take that, assign it to the user object, and then I can save, and everything is, for the most part, good. Maybe not the best way to be able to do it. It's effectively like a deny list that I'm creating there. But it's definitely something that will work and will help to mitigate at least the initial vulnerabilities here. So let's talk about on the WAF side, though, because we're all in the more operational side. A lot of times what we basically will run into is that, it's great to fix vulnerabilities when you first find them. It's the cheapest time to do it. But ultimately, a lot of times, we're in the position where, as operational security engineers and analysts, we get vulnerabilities when they're already in production. We found it in a pen test. We see that there's an active exploit going on. There's kind of that oh shit moment is basically what we call it. When everyone's running around and they say, oh shit, we need to do something about this now, while the developers go and code up the change, and that runs through all the testing regression cycles, and then they push it to production, which can take whoever knows how much time. Some development teams can do it in a matter of an hour. Some will take days. And so you have to create those mitigations to be able to do it. Now, the good news is we've got a couple different methods to be able to do this. The easiest method, and I'm going to say this is going to be the good method, this is probably the first thing that you should do just to shut down a mass assignment vulnerability if you first come across it, is to basically create a custom rule. Custom rules are the Swiss Army knife of being able to just stop bad things, especially bad things that you know about. So what we can do is we can basically create a custom rule that prevents a user from passing in protected fields that are susceptible to a mass assignment vulnerability. And that's the first method. And let me just go in. I'm just going to show you that real fast what this looks like. And of course, I got logged out. So let me get logged back in here. I'm going to show you this one in CloudWAF. I'm going to show you the next one in SecureSphere. So give me just a second here. I'm sorry, WAF Gateway. So we go in here and we look at our api.vetapay site, which is one of my test versions of this site. And then effectively I go into my rules. And I've already created what this basically is going to look like. So if I go into my put user, the predicates and the syntax to be able to create this are pretty simple. We basically specify the URL. So in this case, this is going to be /user. We specify the method that we want to monitor this on. And so in this case, this is going to be the put method. This may exist on the patch method. And then the other thing I didn't mention earlier is because we're basically looking at mass assignment vulnerabilities, I've mostly talked about being able to go and update the methods, but ultimately this can also exist on the post method as well. So the actual initial creation. We've seen instances, or I was able to research and find instances where a post method had it, so a user could actually create an account where they specified their role that they wanted right away. So imagine being able to basically go and say, I'm going to create a brand new account, and oh yeah, please make that an admin for me. So that's the type of thing that you can do with a post method if the post method is actually vulnerable to mass assignment in certain circumstances. So ultimately, the next thing we want to do is just look for whether the param exists. In the instance that we want to just straight up block this from happening, this is all we really actually need, is just to say this parameter exists. And so because we saw this parameter come in, let's go ahead and stop it. Now, you'll have to be careful. You'll have to test this to make sure that the application wasn't also just sending this in across and that you're breaking something. But ultimately, this is a pretty decent way of being able to monitor this. If you also want to be able to go and actually start looking into what the actual payload looks like, we can go in and we can start to actually do not just param exists, but we can do param value. And param value lets you start doing actually some deeper matching against not just the parameter existing, but what the parameter value actually contains in it and whether it contains certain types of payloads. And so this is ultimately what the predicates and the syntax looks like for being able to stop this type of vulnerability. So it's pretty cool. It's pretty easy to do. I actually have an event that's already generated just to smooth along and make the flow of this faster. So you can see here, actually, if I go in, this is my put/user. And this is where I was testing this out yesterday. And effectively, you can see on this one, I had basically parameter name violation, and this one basically showed up straight up on it. So this is giving us the ability to basically go and to be able to quickly identify and block on anything that we see that should not be there. Okay, so let's talk about the second method that's actually the better method. So when we talk about web application firewalls, we talk about the different methodologies that a WAF uses or even a RASP uses. Something that we talk about all the time, at least internally, is the difference between a positive or a negative security model. So what I just did there was effectively creating a negative security model. I said that these are the events that I don't want to see happen, so block them if you see them. A positive security model is a slightly different approach to this, and this is what dynamic profiling does, as well as the API security capabilities that we showed off last webinar in CloudWAF. What they're doing is they're taking it the other way around, where it's instead of saying, tell me what's bad, it says, tell me what's good, and I'll basically just block everything that doesn't fall out, that falls outside of what you've already explicitly told me was good. And this provides a much more comprehensive set of protections against this type of vulnerability. So we're going to show you, I'm going to show you what this looks like in the dynamic profiling feature. Just one word right now on the API security side. We currently do not have mass assignment protection built into that just yet. It's something the team is working on. We actually have figured out some pretty cool methods to be able to actually go and make it easier to detect and block. And so we're going through some QA and doing some various testing on that one right now to understand just how viable this is as a solution. We're investing a lot in this area, so expect to see more of this in the coming years, months even, so as we're going through. But ultimately, if we go into SecureSphere, I'm going to switch over, and the first thing I'm going to do is actually go into my profile. And so let me go ahead and pop this guy open, and I'll talk about, and of course I got logged out. Just give me just a second. Okay, go back into my profile. Okay, so I have my profile for my API. And in here, we can see I have my put/user method. And in the put/user method, this guy is actually already in a lock method, or it's already been effectively locked. One of the things that's kind of cool about working with the profile, there's all the learning that we do. Sometimes the learning, it works okay. There's definitely nuances to working with learning on REST APIs and tuning that has to be done. I'll show you just kind of in a second here what I mean by some tuning specifically for REST APIs because it's not the most intuitive thing in the world to do. But ultimately, one of the great things is you can also go and actually create and update some of these things manually. So if you know exactly what you're looking for, and especially if you have to go and lock down this type of vulnerability after the fact where it's already been identified, then it's pretty easy to be able to go and take something like a Swagger specification, look at the spec, say the spec declares that I should be getting email, first name, last name, phone number, and username, and those are the only variables that I'm going to allow. And then effectively in a lot of Swagger specifications, when you go in and you actually look at those specifications, you'll see all of the variables and parameters and ultimately the types as well, which we support here. And things like the required flag. So I can do things like effectively setting this was a required param. And so basically we're going to ensure that we're actually seeing this come across. Of course, you know, the min-max values and things like that. So you can see here, email, first name, last name, phone number, username is all listed. Last login, which is what I was demoing my mass assignment vulnerability on, does not exist. So effectively here, we're saying that this is it. If we see anything more, let's block the request. And as we go in and we look at the policies now, in order to activate this, let's walk through what this basically looks like. So I'm going to go ahead real fast and just create or show you an existing web profile policy. So we're at the application level and we're at web profile. Now working with web profile policies is something that ultimately there's the default web profile policy that comes out of the box. My recommendation is if you're going to go and you're going to start building out policies based on the web profile, create a new one for the application that you're working with specifically. Because ultimately some of the things that you're going to be looking for and modifying are really going to be specific to that application in particular. And especially with web profile, a lot of these things are by default listed as informative or low because we don't want to generate a lot of noise in the system. But ultimately, some of the things that you're going to want to do, and specifically around protecting API endpoints, you're going to want to probably increase the severity of these things. And so it's good to do this and apply these to just that individual site if you're effectively tuning them. So the web profile that we're going to be modifying in this case, this is going to be unknown parameter. And so basically what this does is this takes the web profile that was created, all the parameters that were basically listed, and I basically said that there were 5 that we're expecting. And if you see an unknown one, how do you handle that? And so this is that flag that does exactly that. So it's going to say if it includes a parameter name, which is not part of the profile, invoke this violation. The default on this one is informative. I'm actually going to set this to high because we knew that this was already a vulnerability in the application. And then the action that I'm going to set is going to be block. And now, of course, I have to go and apply it. And then, of course, the other fun stuff is that when your site's in your site object tree, you're going to have to go in here, make sure you're in active mode. So once you're in active mode, everything should be good. And then ultimately, if we go into our alert screen, of course, I've got lots of noise and different things that have happened in here. Let me find the guy. Here it is. This was my web profile attack that I was launching yesterday. And you can see again that effectively we had my last login parameter name. I had my parameter value of 1971 that I was passing across. All sorts of fun stuff that we probably should obfuscate in here, but this is just a demo system and it was all local, so I don't really care. But ultimately, this is what you would want to do to be able to actually go in to mitigate this type of vulnerability. You can see we're parsing JSON, so no problem being able to actually read the different payloads as part of this. So this is a way that you can go and actually mitigate this pretty quickly and easily. It's your choice whether you want to create a static policy or you want to use a more positive security model like the profile. Ultimately, there's pros and cons to each method. What I generally will find is that ultimately with the custom rules, they can be very, very granular, and it's very easy just to get in there to build a policy that blocks a specific thing, and that's it. The profiles, they require more tuning, especially with the SecureSphere side. It's an art form in its own, but ultimately it provides a really, really comprehensive set of protections to be able to actually go and mitigate this. On the API security side, on Cloud WAF, we're really, really spending a lot of time trying to make this much, much easier to be able to work with and to be able to do. And so we're really looking to mass assignment and the ways that we can basically help to make this a smoother transition for a lot of our customers. Now, I mentioned one thing on the web profile policy, and I'm going to go back in here and just kind of call this out. I'm not going to walk too much in detail into it, but it's really an important one. When we go through and we look at the actual REST API endpoints. So if you go in and we look back to, I'm not going to flip back to it, but if you think back to the API endpoints, one of the things that a lot of customers that have REST APIs protected with WAF Gateway find very quickly is the web profile becomes loaded with lots of noise. And the reason that it gets loaded with lots of noise is because of something called path parameters. A get/user/user ID, which is constantly changing, / some other subpath after that, is effectively an example of a path parameter. Now, what you have to do to be able to ensure that the path parameters are effectively marked and identified as parameters is you have to use something called the URL to parameter plugin. Now, the URL to parameter plugin, it works really, really well if you're okay with working with regex, which is a big thing in its own right. But basically, I'm going to show you just here real quickly what I ended up doing on mine. It's not too bad. You can mostly Google your way through this, and you can use tools. There's regex 101, which is a really, really good one. Lets you put in just like a bunch of samples, and then you can basically write out all of your regexes and test it. And this is probably the easiest way, and that's actually how I wrote these originally. But ultimately what we're doing and what we're looking for here is we're saying that the first path that I'm matching is going to be /user/. The second part that I'm going to be matching, this big long guy here that looks really complicated, but it's actually not. This was all stolen just online. This particular API endpoint is using a set of UUIDs as its identifiers. And so basically I was able to say, just go and give me a regex that matches on UUIDs, and that's what this is right here. So this one's going to be matching on anything that's /user/ and the actual user ID. In the case of anything that falls beyond that, I can have another predicate in here that's actually going to match subpaths beyond that. So you can see this is one right here where I'm doing it on the accounts endpoint, where the accounts endpoint has /accounts /user or some account ID, and then n number of permutations after that effectively. And so that's what this /.star is basically matching. And then we can do some path replacement into it as well. Again, totally not intuitive. If you need help, please just reach out to the community. We'd be happy to help out with some of those. I'm going to also implore, he's not on the call, so I can volunteer him right now, but I'm going to implore Brian Anderson as one of the people to potentially do a deeper dive into this, because Brian is a wizard at tuning profiles and getting them all nicely configured. And this is the type of thing that we definitely would want to do. Okay, so.
Peter, I think he would appreciate that, so.
Yep. Yep, Brian loves me signing up for work. So
exactly.
Okay, so last but not least, just to kind of recap here on mass assignment. Number one, mass assignment is a trivial mistake to make, but it's hard to detect, so it's kind of that perfect storm. Custom rules, they can provide mitigations. They're the Swiss Army knife again of being able to go and stop this. But ultimately, what we want to get to with most of our APIs is we want to enforce effectively design by contract. So your API specifications, the Swagger specs that your developers write, those are a contract. You want them to expose that contract and enforce and adhere people to all the clients to that contract. This is what the general development term of design by contract means. So the positive security models really apply and provide the best protection because they basically are enforcing that contract that gets defined. So really fun vulnerability, but let's go back here. I mentioned before that mass assignment is often a code smell and it can lead to bigger issues. Well, let's review this code just one more time. So we had untrusted user input, we had attacker can guess common sensitive fields, and the application does not explicitly assign values to sensitive items or declare protected fields. Great, all these things were bad. And oh yeah, by the way, this is a parameterized query that's also vulnerable to SQL injection, which is really interesting because usually when we think about SQL injection and we think about the protection mechanisms that you have against SQL injections, dynamic queries are bad, parameterized queries are better, and prepared statements and stored procedures are the best. This is a parameterized query. A lot of times, a lot of the various SAST tools will actually automatically detect that, hey, you're using a parameterized query. It looks good to me, no problems there. Now, ultimately, in this case, we're actually dynamically constructing a parameterized query, which is actually leading us vulnerable to SQL injection. So I'm going to show you just some examples here. So effectively, we have a normal query, what we would expect to see when this gets constructed. Update user, set username, blah, 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 where user set user ID equals the second or the first placeholder, and we're going to return the whole entire object that comes back. Awesome. So you can see here all of the params that basically I embedded into this query as the application was automatically dynamically constructing this. When the user payload is what we expect to see, awesome, no problems. But what happens when I say, well, because we're basically going and it's vulnerable to mass assignment, that means that the keys that I'm passing in are effectively untrusted. So, you know, most of the time when people think about SQL injections and exploiting vulnerabilities, they're testing the values that are associated with an application. They're usually not going in and actually testing some of the keys itself. And so what I was able to do here was say, well, because the keys were untrusted in a mass assignment vulnerability and the application was just blindly assigning them, let's start to see what we can do with the actual keys itself. And this is what was really cool about working with mass assignment and why I paired it with injection is because what we found was that those two things can sometimes ride along together. Mass assignment leading to a SQL injection vulnerability. And so you can see my example here, because it's an update statement, it's actually a really weird one to be able to go and actually update or to exploit from a SQL injection. Most SQL injections that people are familiar with are on select clauses, but they also exist on inserts and updates statements. So you've got a lot of different capabilities here, but ultimately you can see what I was able to do is basically feed in a phone number. So I'm actually telling it exactly what I wanted it to do. but then I'm tacking on a where clause. And unfortunately, in this case, what I've done is I've actually pulled an identifier of a user, poor Craig right here, and I am updating Craig's profile to basically now apply this to his phone number. So not only was it a mass assignment vulnerability and a SQL injection vulnerability, but we also had account takeover as part of this. So this is like the holy trifecta of vulnerabilities. Really, really cool to be able to actually see just how much impact you have on one little line of code can actually lead to a massive amount of harm effectively. And so ultimately, this is bad. We don't want this. So we need to, of course, protect against these types of vulnerabilities. Now, here's the full query of basically what ended up happening. Just to break it down again, we had the users.userid. This is where I basically specified the part of the query that ended up getting attached to it. This and $1 is not equal to $2. Interestingly, I had to actually test this through to figure out and had to really spend some time crafting the SQL injection to basically see if I could get this to pop. And the way to get it to pop and including this was basically because it required parameters, and I basically just had to figure out some way to incorporate the parameters into it. There's probably some other things I could end up doing with this, but there was a lot of massaging that had to be done, and this was a really easy way to do it. And then ultimately, the other part that we look at in here, so we basically have the where clause, we have the tautology, and then we have the comment clause. And the comment clause just basically said, ignore everything else that came afterwards. So what the normal query was supposed to be, where I was actually basically taking the trusted user input and the trusted user ID that I actually wanted to update here, and then return the star. So pretty cool to see. I was really had a blast actually testing this and figuring this one out. More typical queries and examples that you will often see for SQL injections. This is where everyone I think is very familiar, but ultimately it's oftentimes things like this where you have a select query and I'm pulling certain things from the, or certain columns from the users table where email is like, and then I basically am accepting this filter. So this is basically a search functionality on the email. And of course, then you can see some various payloads that all work. The number of payloads and the permutations of this, it's infinite. And I mean that. There is an infinite number of permutations of SQL injections that you can exploit. If you ever watch a pen tester go to work, and a really, really good pen tester in particular, man, they will just have an entire library of things that they will test through and work with. They will have database specific ones. They will do all sorts of really exciting things to just try to bypass WAFs. This is actually the big difference between a good WAF and a bad WAF, is your ability to basically detect and understand the different permutations. Lots of different ways to be able to deal with it. I'll talk about RASP in a second because RASP does something really cool here. But ultimately, what we end up doing with this is we're looking for things like union selects. We've got this or true clause here, which is always going to evaluate to true. This basically allowed me to be able to run this on more users than just who was returned back. The union select is kind of a common way to be able to tie together multiple statements. So this is something where you might say, well, I found a SQL injection, but it's limiting me to only these things that were defined, this select user ID, username, first name, last name. But if I do a union select, then I can start to query different things like password. And so you can start to guess and iterate and pull that information back. So there's a lot more that you can do. And then the other things to think about are ultimately, everyone's always used to seeing like things like or 1 equals 1. That's obvious, easy to block against, but ultimately attackers start to get creative and they do all sorts of fun stuff like or select substring of RSTU31 Boolean, these types of things. So there's lots of other ways that you can basically go and identify these things. It's pretty much impossible to go and write regexes that can capture all the use cases that are across the board. You have to fully denormalize the payloads. You basically have to strip them into their raw forms. Now, as we look at some of the protection mechanisms against this, there's, let's see here, I'm gonna skip to here. The vast majority of them, we block out of the box with WAF Gateway and Cloud WAF. No additional configuration is required. This is one of the strongest things that we do. Now, as I mentioned here, though, there is an infinite number of permutations. So it's not always going to say that we're going to block absolutely everything. And this is where we get into that kind of that negative security model versus positive security model discussion and which one's better. Now, so this is a good way to be able to block it, but ultimately the best ways are to be able to use positive security models. We're saying what we expect to see, and that's what we actually want to use. So examples of a positive security model that will detect and block basically all permutations of SQL injections, because it stops looking at the permutations. It looks more about what the application's expecting, and effectively saying, well, I should never actually get a key that looked like a SQL injection, because I'm only expecting to see first name, last name, username, those sorts of things. And so that's where dynamic profiling really comes in on the WAF gateway. Its ability to learn parameters and then to be able to actually go and block against them, that makes a big deal. It really does stop a lot of these types of attacks, especially as you go through the different permutations. On the API security side, the exact same thing happens with Cloud WAF. Because we're taking that design by contract approach, we're taking an instance of what is the API expecting to see, and we're saying, if it does not match this, let's go ahead and block that, then that's a great way to do it. We just had a webinar on RASP where Raj talked through what RASP is, how it works. RASP takes a totally different approach, and it's awesome. Part of the reason why we bought Previty 2 years ago is because we loved what they were doing. They looked at an old problem and they had a new way of basically solving it. RASP is saying, let's, instead of having to go and worry about applying these negative security models and signatures to a application, let's just go in and let's look at exactly what is getting executed by the JDBC driver or the client library that's interfacing with the database, and let's start to go and actually measure and look for certain indicators of compromise. And so if we go back and we look at some of these types of SQL injections that came across, well, there's certain indicators of compromise in here. We had, in this case, an or true clause. We had comments, so in here. We have things like union select. So we might have databases or tables that effectively we don't want to allow multiple SQL statements to be tied together. These are the types of things that RASP has the ability to go in and actually start detecting automatically. And so instead of worrying about an attacker getting really, really crafty and doing things like, well, I'm going to split up the words union select and I'm going to reconcatenate them later, or I'm going to do all sorts of crazy encoding schemes, RASP just basically says, I'm going to ignore everything that you do up front. I'm only going to look at what's actually going to get executed on the database side right before it gets executed. And then we're going to go ahead and we're basically going to be able to stop anything that's outright malicious based on what we shouldn't be seeing. These are the types of things that are not common for an application developer to write. And so we're going to block those. So lots of really, really cool stuff there. I know we are just about out of time. I had a demo of injection. You guys saw the screenshots. There's some alerts in here too of me doing union select attacks and all sorts of different things. So you can see the predicates and the different things that we're flagging on in some of these cases. So lots of good fun stuff. Anyways, so that is it for today. I know that was a lot of code, and I apologize for people that aren't developers, but I feel it's important to go into the code to understand why these vulnerabilities exist. And I just want to see if there are any questions. And if there's any questions after the fact, please, I'll be able to also answer those in the community. Guys, very much, really, really appreciate it once again. If you have questions, concerns about mass assignment in particular, reach out to me.